What up, Algebra 2 students? Yo, we're going to solve equations here. Um, Stuff that you've done before. You did it in geometry, you learned it in Algebra 1. But I could tell by some of our pre assessments, some of us need to go back to the basics and don't come in thinking you know how to do everything. Start over. Uh, and we start over when we're a little older, and it's beneficial to us. We have a better understanding of things. Hopefully you experienced that when you were adding and subtracting numbers. um, Hopefully we can experience this with equations. What's actually going on? What are we doing and why are we doing it? So don't just jump right ahead and start doing the homework. Just follow me for a little bit. We're going to do this together. Okay. An equation is a balancing act. I'll say balancing act. This equal sign is very powerful. It means that, you know, however much we have over here in terms of weight, this is me trying to do a dumbbell. We have to have the same amount of weight over here. I'm so bad at this. Uh, Now they could look different. Like maybe this is just a 1 ton, 1 ton thing, anvil. I don't even know. And maybe this is like a barbell with a bunch of different weights on it. It's got to be balanced. Okay, it has to be the same. I like to tell my students it's like a scale. Oh, I'm gonna try to draw a scale right now. Oh gosh, what's like the scale you see in like courts or something? You have your thing here. However much you have here, it has to weigh the same over here, though they might be different. Okay, that's what an equation is. All right. Now the equations you are going to see are going to be dealing with numbers, but you can think of a bit of weights. 3x plus 4 equals 13. We'll freeze here. Okay? This weighs the same as this. We are in balance. Okay? But what we're going to try to do is figure out, hey, what do we actually have? What is missing? Typically in equations we have what's called a variable that is unknown. When we have something where it's we have equals something else, there is a very specific a value. It could be multiple values, but there are very specific values that has to be or can be. So our goal when you're asked to solve an equation is, while keeping things balanced, figure out, what does that have to be? For things to be balanced. How can we figure that out? I'm going to be very honest with you. You can use your brain. One option is use your brain. If the left side has to be balanced with the right side, left side has to be balanced with the right side, then the left side, this 3x plus 4, has to equal 13. What does x have to be if after multiplying it by 3 and adding 4, you have to get 13? Well, it's going to have to be 3, right? Because 3 times 3 is 9, and 9 plus 4 is 13. I just figured it out. I'm just using my brain. You're fine. You're fine to do that. However, what if I give you this equation? Do you think you're going to be able to figure it out? Not likely. Once things get more complicated, what we need to learn and what we're going to use are very specific techniques, skills. Think of that as like rules that we're going to follow. We are like picking up a different weapon in our game so that we can help discover and reveal the value for X. We're going to be solving, but we're going to be solving by undoing slash revealing. It's going to just reveal itself to us. Now, what's great about equations, what can you do to it? Anything you want. But you got to do the same thing to both sides so things stay balanced. Let's say X equals 3. Well, I can add 1 to both sides. Would you agree with me that X plus 1 equals 4? Yeah, if X star is 3. So I added 1 to both sides. Maybe I can multiply both sides by 3. Maybe I have 3x plus 3 equals 12. Would you still say that x is 3? Sure. Maybe you add 1 again, and you get 3x plus 4 is 13. Cool. You can divide. You can take things to powers. You can square root. You can do whatever you want, as long as you maintain the balance. The balance needs to be maintained for the equal sign to still work. Okay? So don't do something to one side unless you're going to do it to the other side. Now, look, that's the equation that we had earlier. We're going to kind of back our way and reveal that x equals 3, step-by-step process. I call it using SADMAP. It's kind of just like reverse order of operations. And we're going to reverse order of operations to like help us reveal. Now, I'm going to take you for a little bit of a ride here, okay? So bear with me. I'm going to think about a variable as being like somebody that needs to be saved, okay? If you think about Mario, think about the princess, okay? We'll just use that example. In Mario, we need to save the princess, okay? Now, here's the princess, X. What is being done to the princess? Well, 3 is multiplying by the princess. The 3 is bothering the princess. And the 7 is then being subtracted. If you think about order of operations, what comes first? You're multiplying by the 3, and then you'll subtract the 7. Cool? All right. Well, what we are going to do is undo what's being done. We are going to remove the foes, get rid of Bowser, get rid of the little toads, but in an order that makes sense. Yo, let's take care of the toads who are like bothering her at the beginning of the levels before we take care of like the Bowser, which is at the end of the level. Okay, so like what happens first? The 3x is multiplying by first. Second, furthest away is the subtracting of the 7. We're going to undo that. Now, how we're going to do that is we're going to like make zeros. We're just going to like get them out of there. If I have a -7, a -7 that's like happening, we'll undo that. Add 7. That will undo the subtracting 7 or undo the adding of the -7. So I will add 7 to this negative 7. Boom, it's going to go away. But I can't just do it to this side. I have to do it to the other side. Add the opposite will undo this stuff. Okay, the negative 7 and the 7, you don't have to circle it, but I'm just doing it, is a 0. That's gone. What's remaining on this side, of the wall of the castle, if you think about the equal sign as being a wall or as like a balancing act, is the 3 who's attacking the princess. Over here now, we have 15, okay? Now, to get rid of this 3, we need to undo what's being done. 3 is multiplying by x. What would undo multiplication? Division, hopefully, is what you're thinking. So we are going to divide both sides by 3. You got to do the same thing on both sides. 3 divided by 3 is just 1. All of a sudden, this turns into just 1x. Okay, well, 1x just means we have one princess who has been saved. She's by herself on this side of the wall, or she's done. But what happens is we are revealing what she's equal to. We are revealing the unknown by undoing what's being done. This is a technique. This is a process. This undoing. We will be solving lots of equations this year. And it'll really all come back to like understanding this. Undo what's being done, working backwards. What's happening first to the variable? 3 times the variable. What would happen second? Then you would subtract 7. Order of operations. Reverse that. Get rid of the subtraction and the addition first. Subtraction and the addition. Get rid of this first. Then get rid of the division and the multiplication second. Then we'll get rid of exponents and parentheses. We have reverse order of operations. We are undoing what's being done. Okay? Here, all these variables, we could probably just figure out by looking at it. Q's 3, right? 3 plus 1 is 4. That's fine. You can get that. I'm happy. You got the right answer. You understand what's missing. It's not always that easy, though. So let's just practice. What can I do here? Well, the 1 is being added to Q. The 1's bothering. We want to get rid of it. We will undo it. Undoing addition, subtraction. I don't like to subtract, though. I make mistakes with it. So I'm going to say undoing addition, adding the opposite. Add the opposite. Cool? There. I just revealed it rather than just figuring it out. Here's a tricky one. Something minus 6 is negative 3, okay? Some variable minus 6 is negative 3. Maybe you can think of this right away. A lot of you probably can't. So what can we do? Undo what's being done. How are we going to undo what's being done? Well, we are adding negative 6. Add the opposite. Instead of adding a negative, add a positive. Undo what's being done. We must do it to both sides so things stay balanced. We get 3. Okay? We've just revealed the missing value. And that's it, guys. Undo what's being done. Adding negative 3, add positive 3. That'll undo adding a negative. Add a positive. Undo the adding of the 7, add negative 7. I love adding instead of subtracting because I don't make mistakes with subtracting negatives or subtracting positives from negatives, stuff like that. I love changing subtraction into add the opposite. I hope you are embracing that. Boom. The princess could be somewhere. Doesn't have to be on the left side. Could be here. Could be on the right side. Could be there. Don't worry. What's being done to the princess on its side? I see a lot of you drawing lines through here. Cool. If that makes you understand that we have a wall, and we got to focus on the correct side of the wall, fine. I don't like doing it. I kind of see where it is. Here is the princess. We need to save her. We are adding negative 4 to her. Get rid of the negative 4 by adding 4 to both sides. Adding a negative. The opposite, the undoing of it, would be adding a positive. My missing value is 14. 14 plus negative 4 is 10. Balance. 5 equals b. Okay, here, boom, maybe you draw a line. There's the princess on the right side. That's okay. What's happening? We're adding 5 to it. Undo it. Add a negative 5. Well, what we get is 0 on the left side. We still have the equal signs, and on the right side, we have b. That's fine, guys. You don't have to write it as b equals 0. Um, we are stuck in the United States of America. That's where we live, okay? The United States of America, we read English or Spanish, and both languages read books from left to right, okay? There are other languages that don't do that. There are some languages that like to read things from right to left. There's some languages that like doing things up and down. Don't be stuck thinking like an American, okay? Math is universal. This can be read 0 equals b, but this also could be read b equals 0. I'm okay with you leaving it like that, provided you know it's the same thing as this, okay? What's happening here? 4/5 is being added to v. We got to get rid of that. Add the opposite. Uh-oh, we have a problem. We don't know what this is. Well, if we make it similar slices, we have like terms, we can combine them. -3/10 plus -8/10. If this is 4/5, turns into 8/10. They're similar slices. I have -11/10. Okay? What's happening here? Values are being multiplied. Values are being divided. What are you going to do? Undo. Undo multiplication. Division. Or instead of dividing, you could multiply by the reciprocal. Remember, we talked about this in day 1. Dividing is the same as multiplying by the reciprocal. So I'm going to show you 2 things. You divide by 3, sure. But you could also decide, instead of dividing by 3, to multiply by 1/3. It is still undoing multiplying by 3. This is maybe not helpful here, but it'll be helpful when we're dealing with fractions. C equals 7, or 21 times 1/3 is 7. Boom. If we have stuff being divided, undo division, undo it. D is being divided by 3, multiply by 3. We have undone what is happening to D, giving us just D. What we're doing is actually creating a 1. 3 divided by 3 is 1. It can be simplified to be 1. 3 divided by 3 is 1. It can be simplified to be 1. Dividing by 4 or multiplying by 1/4 will undo multiplying by 4. -4 divided by -4. -4 times 1/4 will make a 1. Just leave us with n. We'll undo. Will help us reveal the missing variable. Multiplying by -2 will undo dividing. Boom. Okay? Fractions are tricky, though. 2 things you can do. Okay? What is happening? X is being multiplied by 2/3. Maybe in the past you've always thought, how do you undo multiplication? You divide. Sure, this works. This is fine. But then you have to figure out what's 10 divided by 2/3. Well, we worked on this, right? We said keep the 10, change this into a 3/2, multiply across, you get 30/2, or you could figure out that it's like 10 times 3/2. You could take the 10 divided by 2 and then multiply by 3. You get 15, sure. Okay? Or, like I said, instead of dividing, multiply by the reciprocal. Instead of dividing by 3, multiply by 1/3. Oh, maybe it didn't make sense there, but here, instead of dividing by 2/3, multiply by 3/2. 3/2 times 2/3 will be 6 over 6, which is 1. Boom, the number's gone. It's replaced by 1. You just have 1x, you just have x. And maybe it's a little bit easier to do this right away to get 15. Okay? Try both. We could either, and this confuses a lot of students here. 2x divided by 5 equals 8. What you could consider is like the 2's being multiplied by the x, and then we're dividing by 5. We could do multiple steps if we wanted to. You could say, well, the 5's happening last, so we're going to undo that first, like 2 times x divided by 5. Let's get rid of the 5 first. This is totally fine. And then let's get rid of the 2, undo it to reveal x is 20. But if you remember from like the last lesson, if you got a variable up top, you can easily just move it to the side and it's fine. You realize, you have 2/5 of an apple or something. The 2/5 is being multiplied by x. You can get rid of it by either dividing by 2/5, but what I like to do is multiply by 5/2. And I get 40/2, which is 20. Boom, just like you did here. Pick away. These are just tools to go into your arsenal, okay? Tools that you can use. Undoing things. Undo the 4 times the m. Divide by 4. 10/4. Can't do that. I can divide the top and bottom by 2. It becomes 5/2. Where is the variable? Here. This is important. Find it first. So many people were stuck working on the left side, and you're like, 1/10, 1/10. Multiply by 10. Divide by 1/10. No. 4/5 is being multiplied by y. Get rid of the 4/5 by either dividing by 4/5 or multiplying by 5/4. The y stays on that side. We've just saved the princess. We multiply straight across. Get 5/40. What's 5/40? Divide by 5. It's actually just 1/8. What's happening to w? Divided by 7. It's back over here. Undo what's being done. Multiply by -7. Undoing dividing, multiply. 7 over 1, 2 over 3, -14 over 3. Done. Okay? Now, to undo things, reverse what's being done. Multiplication is affecting the x before you're going to add. Like, what would be the order of operations here? Multiply the value by 5, then add 10. To reverse that, we will get rid of the things in opposite order. To undo things, we got to go in opposite order. We got to get rid of the adding and subtracting first before we do the multiplication and the division. So I will choose to be like, get rid of the 10. That's the last thing done. We are undoing. We're backing out. We're revealing. Add the opposite or subtract. I like to add the opposite so I don't make mistakes with negatives. Now, this has gone into 0. We have a 25. Now, 5 times x. 5 is being multiplied by x. Let's get rid of the 5. Let's undo what's being done. Divide by 5, divide by 5. X is 5. 25 divided by 5. Okay? That's what I just did. Okay? More of the same. Here's the x. Look, sometimes the variable's on the right side. We'll do this on purpose so you're ready for it. Identify where it is. What's happening to it? 2 is being multiplied first. 6, the -6 being added second. What do? Undo. Get rid of the stuff being added and subtracted first, then the multiply and divided second. Could you have just figured this out by looking? Yeah, a lot of these questions, these equations, you figure out just by looking. And I'm okay with that. But again, when things get harder, this technique will always be there for you. This new skill, this new weapon in your arsenal will always be there for you when the equations get harder. Add a -3, add a -3. Do it to both sides. Keep things balanced. Divide by 4. Divide by 4. Uh-oh. 7 can't be divided by 4. Okay. The answer is 7/4. I bet you couldn't figure that out by yourself. There's R. Don't worry about the -8. Don't worry about that yet. Worry about this -8 here. That -8 over here. This 3. Add the opposite, add the opposite. Ooh. This -8 plus 8 is 0. Hey, that's okay. The equal sign stays there. Oh, divide by 3. Well, we've done this before. What times 3 is 0? 0. Your value could be 0. It's fine. That's its value, so that things are balanced. That you've been able to figure out. Undo. What should be undone first? The 4. What then should we undo? The 6. Reverse order of operations. Undo to reveal. Techniques. New tools, new weapons. Boom. Princess is saved. Here, this one's straight. Like, I don't know this just by looking at it. Well, this technique will help. What does x have to be so this is balanced? So that the equal sign is true. Get rid of this 2 first. It's bothering the x the last. Okay, it's 3/4 times x plus the -2. Undo that. Reverse order of operations. Divide by 3/4 if you'd like to. It's the same as multiplying by 4/3, which I like to do. 40/3. Can you divide 40 by 3? No. Can you divide 3 by 2? No. You're done. That's your answer. Bet you wouldn't have gotten that. This tool is there for you. Adding 4 first. Multi-step this or one-step it. You could think, 3 is multiplying by x first, then dividing by 2. So you can get rid of the 2 first to undo it. You're going to undo the 2, then undo the 3, multi-step it, or one-step it, multiply by 2/3. I think a lot of students like to multi-step this because it's like the 2's bothering it last. So let's worry about it first. And then we'll worry about the 3. And that's fine. You could do this with all fractions. Even like this guy right here. You could have turned this into 3x over 4 if you wanted to. And you could have multi-stepped it. Multiply by 4, divide by 3 if you wanted to. It's up to you. But look out, watch out. Sometimes there's going to be groups of princesses that need to be saved. Okay? Like, I got 6 x's. I got 3, and I got -9 x's. 6 princesses. -9. Or like, hey, we got things attacking this set of princesses, things attacking that set of princesses. We can go back to like apples and oranges. Like, what can be done here? Well, what we like to say is like, same side. We can just combine. Same side combine. I tell this to my calculus students. Pretend this was just like a question from the last 2 days, and I didn't have this part over here. And I said, hey, what's this? Just pretend that's not there. We did this like on day 2. Well, you'd say I got 6 apples and negative 9 apples. Or I have 6 apples, I owe 9 apples. I owe 3. Can you add this 3? No, you can't, right? Because they're different types of fruit. What we did is just kind of what we did day 2. It's just on one side of this equation. Boom. Now we could say, actually, this is our situation. Here's what's being done to like a variable. And now we can undo things. Getting rid of the adding and subtracting first, then getting rid of the multiplication and division second. We'll worry about parentheses, we'll worry about exponents and stuff like that in this class. 10 over negative 3, that's fine. Maybe you want to write it as negative 10 thirds. That's good. Same side, you guys like to draw a line? Okay, on this side, what do we have? 3 x's, 2 x's, 3 princesses, 2 princesses, a total of 5. Negative 13 toads, negative 7 toads, negative 20 toads, negative 20 oranges, That's all on one side. Same side combined. But things have to be equal, they have to be balanced. Boom. We still have that other side. Now we can undo what is being done. Look, right side. You guys use your line. Go ahead, use your line. Here's your wall. What's over here? Negative 2x's and negative 4x's. Combine those. I got negative 6x's. Negative 20. Boom. There's your situation. Let's reveal. Honestly, I like doing this because I think it's easier than trying to think about the solution. Sometimes it's easy to just see. It's like, the answer's 2. The answer's 4. But using this technique actually means we don't have to use our brains as much. Sure, we have to do some calculations, but it's a very nice, simple technique. It's very much like thinking like a computer. Like, how do we take this puzzle, solve the puzzle? That's why I think of math. It's just puzzles. We are solving these puzzles using the tools at our disposal. I'm okay with this. Look, the negative 6 and the negative 6 makes a 1. The x stays on the right side. 24 divided by negative 6, negative 4. That stays on that side. This is fine. You can read this, x equals negative 4. You can read things right to left. You don't have to be stuck to left to right world in America. I think Arabic is read right to left. Hebrew is read right to left. So if you're like in Israel or in Saudi Arabia, maybe that's a bad example. United Arab Emirates, Bahrain, Qatar, where the World Cup is being held. If you're in Qatar, you read your signs right to left. So you're more comfortable, and those students in Qatar are more comfortable with that. You are more comfortable with the other way, and it's okay. Don't let minus signs disappear. This is a negative 5. This is a negative 1c. This is a negative 1m over 2. I always like to change subtraction symbols and to add the opposite, okay? Get rid of what's bothering. Negative 5 and the negative 6. Adding and subtracting gets undone first because it goes last in the order of operations. Multiplication, division gets undone last because it's the first thing that happens. Can't simplify. Your answer is negative 4/5. Boom. What's happening? 9 is being added to negative 1c. Add the opposite first. Get rid of the negative 1. What's being multiplied by the c? Divide by negative 1. Or take the opposite of both sides. Again, like what can you do? Maybe you just like write it as negative c equals negative 22. Maybe you're like, can I just take the opposite of both sides? Like, like, isn't c just 22? Yeah, it's like as long as you do it to both sides, you're fine. I'm like doing an operation to take the opposite. Get rid of the 4. It's bothering it last. Maybe we multi-step this. Multiply by 2, then take the opposite. Up to you. Probably what I would do. Now, one thing I haven't mentioned, which your teachers in the past have always mentioned, is like, yo, you got to check your answer. Uh, I'm not huge on checking my answers unless I'm not sure if it's good or not. A lot of students make mistakes with checking answers, and then all of a sudden they second guess themselves. So what you can do is like just make sure. Hey, does this actually work? Go back into the original. And this is when maybe it's easier to think instead of like showing all the check your work stuff and like you students hate doing it. Honestly, I don't like doing it either. But it's good to mentally think, or if you have a calculator, mentally type in to check. Does negative 18 actually make things balanced? Negative 18 divided by 6 is negative 3. Negative 3 plus 4 is 1. We have found the right value because that's the value that it must be so things are balanced. Okay? Careful when you distribute, especially when there's minus signs around. The correct way, what I always tell you to do. Same side combined, right? We're on one side of the wall. This negative 2, I would distribute the negative 2. I got rid of the minus sign by making it add the opposite. That's a crucial step. Add the opposite, so don't subtract. Now, again, we still have the wall. We're just looking at the right side. What do we got? Oh, a 6 and a negative 4. Two different types of oranges. Same side, combine. Same side, combine. Don't add 4. This is a common mistake. Add 4 and add 4. If you do that, what are you doing? You're adding 8 to this side without adding anything to that side. You're breaking the rules. Now, what could you do? You could add 4 to both sides and then subtract 6 to both sides or add negative 6 to both sides. You could do that. That's fine. That's fine. Maybe you want to do that. It's great about math. There's always multiple ways to do these things. I am going to combine instead of doing two different things. And then I will undo. What you can't do, guys, is not change this minus. Here's what so many students do. They're like, all right, let me distribute 6 minus 2x. That's got to be a plus 4. Boom, already wrong. What's the difference? It should be a negative 4. It should be a negative 4. You owe two groups of this. Okay, you're subtracting two groups of this. Wrong. You're going to make a mistake if you do that. Okay? Finish off with a couple examples. Man, I literally could go in and just like start, and if I see a minus sign, maybe I'm putting a 1, making plus a negative 1. Maybe I'm doing plus a negative here, making life easy on myself. Distribute. Negative 2 times negative 1, D. Positive 2, D. Now we undo. 4x plus negative 8 plus 2x equals 12. Same side of your wall. Combine. Don't subtract 2x. Subtract 2x. What are you doing? You are subtracting 4x from one side of the wall. You'd have to do it to both sides of the wall. But if you subtract 2x from like this side of the wall, it's like, oh, well, now x's are over there. It doesn't really help me. Same side combined. I forgot to solve this. Undo. Undo. Simplify first, just like we did last class. Undo. Here's the variable there. What's bothering it? Add the opposite to undo. Divide to undo. Okay? I'm going to leave the other examples out. I don't want to deal with fractions right now, and I'm out of time. I think we have enough. I'll make sure I do all the homework problems. Distribute. Same side of the wall, combine. Same side, combine. 1x, I owe 3 x's, I owe 2 x's. Undo what's being done. There it is. Here's the equation, here's the wall. You got to work on the same side. Oh, this is a good one because the solution here is 0. Okay? All right. I hope this is helpful. It's good to practice, good to relearn. Starting over, making sure our fundamentals are strong before we get into new stuff. Later.